Welcome to the CompTIA A+ Prepcast presented by baremetalcyber.com. IP configuration is a foundational concept in networking that determines how devices communicate on a local area network or with external services across the Internet. Each system must be properly configured with the correct IP settings to ensure smooth connectivity, resource access, and communication with other devices. These settings include the IP address itself, the subnet mask, the default gateway, and one or more domain name system servers. A single misconfigured value can prevent the system from accessing shared folders, printers, or web services, making accurate configuration an essential skill for any technician. There are two primary methods used to assign IP settings to a Windows device: automatic assignment using DHCP and manual assignment using static addressing. DHCP, which stands for Dynamic Host Configuration Protocol, automatically assigns addresses to clients from a pool managed by a router or a DHCP server. This method is efficient for general-purpose systems like workstations and mobile devices. Static IP addressing, on the other hand, is configured manually and is typically reserved for systems that need consistent access points, such as servers, printers, routers, or managed switches. When using a static IP configuration, several fields must be filled out manually. These include the IP address, subnet mask, default gateway, and one or more DNS servers. Each of these values plays a specific role in determining how traffic is handled on the network. Missing or incorrect information in any of these fields can result in limited or no connectivity. For example, an accurate IP address without a valid gateway will allow local communication but block Internet access. The A+ exam often presents scenarios requiring technicians to analyze or correct these settings. The IP address itself defines the identity of the device on the network, while the subnet mask determines which range of addresses are considered part of the local network. A common subnet used in small and home office networks is 255.255.255.0, which corresponds to a /24 subnet. In this configuration, devices with matching network portions of their IP addresses can communicate directly. If the subnet mask is incorrect, systems that should be on the same local network may not recognize each other as reachable. The default gateway serves as the exit point for traffic leaving the local subnet. It's typically the internal IP address of the router or Layer 3 switch that connects the internal network to the Internet. Any device that needs to reach systems outside the local network must have the correct default gateway configured. Without it, even properly assigned IP addresses and subnets will not allow the system to browse the Internet or reach remote sites. Technicians often identify gateway errors when users report that local access works but external browsing fails. DNS, or Domain Name System, server settings are equally important. DNS is responsible for translating host names, like www.example.com, into numerical IP addresses that devices can actually use. If the DNS settings are missing, incorrect, or pointing to a non-functional server, users will not be able to browse by hostname, even if raw IP connectivity still works. This leads to situations where PAing commands to an IP address succeed, but browsing fails. DNS misconfiguration is a frequent cause of support tickets and a common exam question topic. Many networks use public DNS providers to enhance reliability or improve security. Common public DNS options include Google's 8.8.8.8, Cloudflare's 1.1.1.1, and OpenDNS. These services may offer faster resolution, more consistent uptime, or additional filtering capabilities. Some are used to block known malicious domains or enforce content policies. Technicians may switch users to a public DNS provider when the default settings from an Internet service provider are slow or experiencing issues. By default, DHCP assigns both the IP address and the DNS settings to each device. However, these can be overridden manually in the adapter's properties. This allows technicians to keep dynamic addressing for IP and gateway fields while specifying a different DNS server. This is particularly useful in environments where the default DNS settings are slow, incomplete, or subject to redirection. It also allows individual devices to opt out of network-level filtering without changing settings for the entire subnet. To configure these settings in Windows, you begin by navigating to the Network Settings section. Go to Settings, then Network and Internet. Then click on Change Adapter Options. From there, right-click on the desired adapter, select Properties, and choose Internet Protocol version 4. To set manual values, select the option to use the following IP address and fill in the required fields. To verify that the configuration has been applied, use the command line tool ipconfig/all. This will display all active IP settings for every adapter. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. Several command line tools are available to help manage and troubleshoot IP configuration issues. The command ipconfig with the /release option tells the system to give up its current IP lease. Running ipconfig with /renew then requests a new address from the DHCP server. This combination is used when a device is stuck with an outdated or incorrect IP configuration. Another useful command is ipconfig /flush DNS, which clears the DNS resolver cache. This can resolve problems where name resolution is failing due to cached incorrect entries. For testing DNS behavior specifically, the nslookup command is a valuable diagnostic tool. nslookup allows technicians to manually query a DNS server to see if a hostname resolves to an IP address correctly. You can also specify which DNS server to query, making it helpful for testing against internal or external name servers. If a device is using the wrong DNS or cannot reach the server, nslookup helps isolate the failure. It's a direct and fast method for identifying where resolution problems are occurring in the network path. When a system is configured to use DHCP but cannot contact a DHCP server, it may fall back to an address in the 169.254 range. This is known as a link local address, or APIPA short for Automatic Private IP Addressing. This allows communication with other nearby devices using similar fallback addresses, but does not support access to the Internet or other subnets. Seeing an APIPA address on a system indicates a configuration problem, often caused by network cable failure, wireless dropouts, or a DHCP service outage. Subnetting errors are another common cause of network communication failure. If the subnet mask is incorrect, devices may not recognize each other as part of the same network, even when they are physically connected and using correct IP ranges. Duplicate IP addresses also cause disruptions, typically resulting in conflict warnings or one device losing connectivity. A mismatch between the subnet, gateway, or DHCP scope can create routing loops, isolate systems, or break Internet access. Knowing how to detect and resolve these errors is a key troubleshooting skill tested on the certification exam. The wrong gateway setting can cause confusing issues where local access works, but the user cannot reach external websites. In this case, the device may be able to ping other local systems or printers, but cannot access the Internet. The ping and tracert commands can help confirm whether traffic is routing through the expected path. If the gateway address is mistyped or unreachable, external communication will fail. Verifying that the gateway matches the router's internal address is a basic but critical troubleshooting step. Windows offers a feature known as alternate configuration. This allows a secondary static IP profile to be assigned to an adapter that normally uses DHCP. If the DHCP server is unavailable, the system will fall back to this alternate profile instead of generating an API/IPA address. This feature is helpful in mobile or semi-managed environments, where users occasionally connect to networks without DHCP support. Technicians use this feature when setting up laptops that operate across multiple physical locations. IPv6, or Internet Protocol version 6, is the successor to IPv4 and is gradually being adopted across networks. IPv6 addresses are long and use a colon-separated format. They are usually assigned automatically using stateless address auto-configuration, also called SLAAC, or through DHCP version 6. In most small and mid-sized environments, technicians do not manually assign IPv6 addresses. However, familiarity with their appearance and behavior is important. The exam may ask you to recognize valid IPv6 addresses or identify problems with dual-stack configurations. Some networks use a hybrid approach by assigning static addresses through the DHCP server. This is done by reserving a specific IP address for a device based on its MAC address. To the client, it still looks like a dynamic assignment, but the address remains consistent. This is ideal for printers, security cameras, and other infrastructure devices that must be reachable at the same address at all times. It also reduces human error by centralizing control of static assignments. A realistic scenario may involve a user who cannot access the Internet. The technician runs ipconfig and notices that the device has an IP address but no gateway or DNS servers listed. This suggests that the DHCP lease expired or failed, and the system is operating with partial information. In another case, a user manually entered static IP settings but left the DNS field blank. In both examples, switching the system back to automatic addressing or entering the missing information resolves the issue immediately. Documenting IP configurations is essential, especially for static setups used in infrastructure. Keeping track of which address is assigned to which device prevents conflicts and supports faster troubleshooting. Documentation should include the IP address, MAC address, assigned hostname, and physical location when possible. Larger organizations use IP address management tools, known as IPAM, or integrate IP tracking into their asset inventory systems. This process is critical for auditing, compliance, and efficient expansion of the network. To summarize, proper IP configuration is essential for stable, secure, and functional networking. Key settings include the IP address, subnet mask, default gateway, and DNS servers. Whether assigned dynamically or manually, these values must align with the network's structure and purpose. Misconfigurations are a leading cause of connectivity issues and are frequently tested on the A+ certification exam. Understanding how to assign, verify, and troubleshoot these settings prepares you to manage both simple and complex networking environments effectively. Thank you for listening. Please visit baremetalcyber.com for more cybersecurity information, podcasts, books, and more.